Okay, sorry about any mix up. So don't worry, don't worry. I'm speaking now. Okay, two of us are here, myself and Dr. Ojo. That's why you see that it is going, the host is changing. So Dr. Ojo took you last week, and you are familiar with me. I've been taking you for a while now. So the two of us are here. And so don't worry, the host might be changed between myself and him. We have done taking so much time now. So can we move on? Thank you. I like your responses and the emojis. So it's making me to know whether you can hear me or not. So good afternoon, everyone. How has your week been? Yeah. Thank you very much. Thank you for all the love emojis. So that means you had a good Valentine. The Valentine is still in your body. Abby. Okay, good. So yeah, let's come back to chemistry. Thank you very much. Let's come back to chemistry. So um now we are in week 5. You know, the program is supposed to go for 6 weeks. This week we are supposed to do our assessments, but we found out that we have not covered so much as we ought to. And this is because, like today, we are just starting 2:15, trying to make sure everything is okay. And from my end, from your end, sometimes we have network glitches. So I hope you understand why all this has been like that. But because of time, I don't want us to waste much time again. Um, the YouTube link has been posted for those that are unable to follow on the LMS page or the Zoom, maybe because of one reason or the other. You can watch on YouTube, you can watch now, you can watch later. So welcome to class. And I will quickly want us to go back to what we did last when we met, talking about atoms, compounds, elements, molecules. And, I gave us an assignment, and that is what I want us to look at. Now, don't worry, if you have not seen responses on your pages, the discussion page, because we have been looking at it. I've seen a lot of responses on the discussion forum. I saw some people talking about their challenges, and we are looking for at those challenges and finding the best way to deal with those challenges. So don't worry. You may not get responses now, but don't think we are sorry about that. Don't think we are underrating or overlooking whatever it is that you are saying. Many people are talking about the fact that they are not getting information on time, that lecture times are late. I mean, they find it late. They are attend to mark attendance, to write assignments, and so on like that. Now, but what I want to need you to know, while I agree that there may be challenges here and there, especially communication barrier, but you should be familiar with the fact that in an higher institution, you would be the one to look out for information. Unlike in colleges and secondary school, where they gather us, they tell us, they inform us about the information. Oh, I want to give you an information. Everybody come together. This time around, you will be the one to find out the information. You go on maybe the university website, your departmental website. When you come around your notice boards all around, you go there, because nobody is going to ring bell for assembly and say, oh, this is what we have at this time, and so on and so forth. So please take note of that. It's not as it's not. I agree with you totally that it's not the best of methods, especially because of the factual issues. Nonetheless, you should note that you will be the one to look for information. Like when I got to class now, I saw some people talking about What is it? What is it? Beg your pardon. Just hold on for me. Yeah. Some people were talking about attendance. And I saw some people saying the lecturer has not talked about attendance. Don't stress it. The lecturer is not going to talk about attendance if the lecturer has already put the information where necessary. So where is it necessary on the LMS page? So you are going to be looking at your notice board. Your notice board for now is your LMS page and the website, and maybe your Telegram page. On the Telegram pages, we are not we are at the liberty to post information just randomly, except that which is from the items, the management systems department that do your IT issues. So here you look at the LMS page, you have your timetables. So your timetable tells you when your class is to start. No lecturer is going to come and call you, or it is not the job of anybody, it's your own job. That's part of your duties to look for the time of your lecture. So now that you have timetable, you get it. So you know where your time lecture. So about lecture, people saying they don't know about lectures. I understand if you are late to submit assignment or to find out if there are assignments. I understand that, but you cannot be late to find out that there is a lecture. And concerning signing attendance, if the class is 1 to 2, if you didn't attend between 1 and 2, there is no way you can sign your attendance and say you are late to find out. It will always be there. So it is your job to look at your LMS page. So the first thing we want to do is to go to our LMS page. So I start sharing my screen now. I'm supposed to have let me see if I can quickly have a co-host today. I have a co-host today. If you want to be a co-host, can you signify? You can only be a co-host if you understand what to do when I have an issue with my network here. So I can't see hands up. Can you hear me at all? Oh, plenty people want to be co-host. So the first person I'm seeing here is Onosoya Oluwamayokun. Mayokun, I'm asking you to unmute and tell me, please, do you understand what it is to be a co-host?
Yes, ma.
Okay, so
Good afternoon, ma.
good afternoon. So I'm going to make you my co-host for today. They have made you my co-host for today. I've confirmed that you're my co-host. That means if I have issues with my network, you can let me know. So I don't know anybody, I just picked the first, excuse me, the name I have here. So let's start with our, so that we don't waste too much time. I will do as much as I can. So this is my LMS page. This is supposed to be my LMS page. Hope to see. Sorry. I've gone too far. I'm not supposed to go that way, but I'm here. So this is my LMS page as a student of UI offering general chemistry. This is my LMS page. And I want to believe that this is your LMS page too. So on this LMS page, you have divided it into welcome, week 1. So you know you are in week 5. So just come to week 5. Every information you need for week 5 will be posted here and added here. Week 5. So this is week 5. There may be issues with timing because some information, like you see, it was before. If you came earlier today, you find only assessment there. But we have been told we can give our roundup lecture, then put assessment. I will talk about the assessment later. Can you see that? Can we all see this? Mayo, can you see this?
Yes, ma. Yes, ma.
Okay, that's good. So Mayo, is your mouth too. So whatever he says is what everybody is saying. Sorry about that. Now, somebody says it doesn't see attendance. Can you see attendance for week 5 here? That's where I'm scrolling. It says, give your name. So if you scroll this, I did it that last week. So last time I was here, so I don't want to waste time going to that. So that now, I've not posted anything here deliberately. I will post after today's class. Now, let's go to something else. In week 3, which was the last time I was with you, I gave you an assignment and there was a discussion forum. This assignment on atomic theory. So let's quickly go and look at that assignment. If you click the assignment, many people responded. Some responded late. You know, the time you responded, it will be there. And after a while, it will stop taking your responses. So, but it's there. Now, I want to look at your, please, solution to the, Marokun, can you see my screen?
Yes, ma. Yes, ma.
Please, many people are raising up their hands so that I can know whether you have an issue or not. If your issue,
There's no issue, ma.
and don't worry, Mayoko, all the people that are raising their hands, please let me know now. If you don't have any issue so far, please put down your hands so that we can move forward. Fatola, do you have issues? Let me ask you to unmute. Fatola, your hands is
Yes,
up.
ma'am.
What's the issue?
Good afternoon. Ma, I could not get through the attendance. I kept tapping it and staying open.
Okay. Now, concerning attendance, does any other person, Mayoko, have you signed in your attendance?
Yes, ma.
So let me ask somebody else. Who else is this? Abibat, I'm going to ask you to unmute. Fatola, please put down your hands. Please put down your hands. Abibat, what's your issue?
Yeah, I have not been able to mark attendance. You said we have to join a group first.
It says you have to join. I didn't get that.
To mark the attendance, it says you have to join a group first.
Okay, put down your hands. Just put down your hands. If your issue is about attendance, the rest that are putting down up their hands, Blessing, Ojo, Abioye, all the people whose hands are up, if it's about
Yes,
attendance,
mama. It's breaking, ma.
network is breaking. It's not, I don't think it's from me, but don't worry. If your issue is about attendance, if your hands is up and your issue is about attendance, kindly put it down so I don't get distracted. If your issue is about attendance, kindly put your hands down. If your issue is about attendance, kindly put your hands down. Okay. I think I have only one person left here. Samuel, what's your issue?
Good day, ma.
Yeah, please. Hello, I'm hearing you. I've asked you to unmute.
Okay, yes, ma. See that, ma. I can't log into my LMS portal, so I
That's
can't see
beyond
assignment.
me. If you can't log into your LMS, that means since assignment has been there since 2 weeks ago. So if you cannot, how are you logging in now? You are in now. Okay, you are
Please, through
just
someone.
okay, somebody sends Zoom to you. Okay,
Yes.
that one is beyond me. It's items issue. So please,
Okay.
you message them on the Telegram page, the admin on the Telegram page, send them a message and make your complaints to them. Thank you.
Okay.
Thank you very much. Can you put down your hands now? Okay. So are we still together? Hi, Okun.
Yes, ma. Yes, ma. Yes, ma.
Thank you. So let's look at our assignments. Okay. It says that the fact that isotopes exist, that's question number 1, contradicts which of the following fundamental laws of chemistry? Remember,
Sorry, ma. The screen
yes,
is still on. The screen is still on the homepage of the LMS, ma.
so you're not seeing what I'm saying.
No, ma.
Oh, okay. Let me do that again. I'm coming. Okay, sorry. Thank you for bringing that to my attention. Sorry. Can you see this now? The
Not yet.
assignment.
Yes, ma. Yes, ma.
Can you see the assignment now?
Yes, ma. Yes, ma.
Oh, thank you. Okay. So it says that the fact that isotope exists contradicts which of the fundamental laws of chemistry? Now, we have talked about 3 fundamental laws of chemistry. Let me quickly go there and show you the fundamental laws of chemistry that we have talked about in this same class. I don't want us to, sorry about this, in case you miss it. Yeah. Now, Mayokun, can you see my screen? Talking about,
Yes, ma'am. Yes, ma'am.
what are you seeing on my screen?
Dalton's atomic theory.
Very good. Thank you very much. Thank you very much. So now, from this that we did, I'm sure if you were in class, you would have seen it. Look at it very well. We treated this Dalton's atomic theory, which was the basis for all laws of chemistry and what we are going to be doing. And I discussed that we now have modern atomic theory due to a paradigm shift. That is, the existing observations that we are witnessing cannot be fully explained based on these laws. So that was why we have the Dalton's atomic theory and the modern atomic theory. And now, the Dalton's atomic theory is, I mean, three fundamental theories that, well, let's say 4. Matters are made up of tiny indivisible particles. That is, they cannot be, cannot be divided further. Atom is the least. That is Dalton's atomic theory. It says that atoms can neither be created nor destroyed. That's law of what? Can somebody say what law is this? If you can say what law is this, can you raise up your hand? Let me see your hand. Atoms can neither be created nor destroyed. Akinlade. Am I right?
Yes, ma'am.
Okay. What law is
It's
this?
law of conservation of mass.
God bless you. That's beautiful. Law of conservation of mass. Now, atoms of the same element are identical and have the same mass and chemical properties and are different from atoms of other elements. What law is this one? You still want to answer? Adetoro. I've asked you to unmute.
Good afternoon, ma. That's the law of constant composition.
Law of what?
Constant
Constant
composition.
composition. Okay. So I may ask you to explain. No, that's good. Then we have atoms combined together in simple whole number ratio. What law is that? What law is that? I'm asking Chuku Ebuka. What law is this? I've asked you to unmute.
Law of
What law
multiple
is this?
proportion.
Law of multiple proportion. Very beautiful. Law of multiple proportion. You guys are good. So those are the laws. Do in the modern theory that says that this one that says atoms of the same elements are identical and have the same mass and chemical properties, and they are different from atoms of another element, is now, I mean, subjected to changes because we find out that isotopes exist. Isotopes are atoms of the same element, which does not have the same atomic number. So the answer to that question, please, let me go back to here. The answer to this question is law of what? Let me ask somebody to now answer the question. Adenekon testimony. I've asked you to unmute testimony. Is it testimony? Your hands are up. Everybody's hand is just up. Yeah, testimony. Is it you? Sorry, wait. I want testimony to unmute. Testimony, can you unmute?
Yes, ma'am.
Oh yeah, what is the
Good
answer?
afternoon, ma'am.
Good afternoon.
It's law of constant proportion, ma'am.
Look at what you have.
Law of constant
Law of what? Don't look at what you have on the screen. Law of what?
proportion.
It's not constant proportion. Let's see. Emmanuel Igboke. Are you the one I'm asking to unmute? Wait, I want to be sure it's you. Is it Emmanuel? Emmanuel, is it you? Is that you? Hold on. I want to be sure I'm asking the right person to unmute. Who is this? You guys, oh yeah, everybody put your hands down. Because I don't understand what you want me to do now. Everybody's hand is up. Help me now.
Good morning, ma.
Who is this? Oluwole Omolola, Abi?
Yes, ma.
Okay, what's the answer? Help her.
Law of conservation of mass, ma.
Hmm.
Yes, ma. It's me, Emmanuel.
Yeah, Emmanuel, you say your own. What's the answer?
Oh, it's the law of constant composition.
Good. Now, what's
Law of
my
constant composition.
composition? There's nothing like constant proportion. So, did you get it? Where is that my first girl? I can't remember her name, so I'm sorry. Testimony, yeah. Testimony. Hello, testimony. Do you get what you did wrong?
Yes, ma.
It's not constant
Yes, ma.
proportion. It's constant composition. So we get that?
Yes,
So
yes, ma.
the
Thank you, ma.
answer is law of constant composition. Oh yeah, let's put our hands down so that I can move on. If one of you are raising, what are you raising your hands for? I don't understand. There is no, help me now. Put your hands down, please, so I can move on. Thank you. I'll call you. Don't worry. Thank you. Good people. You are very good. So this question number 2, it says in a cathode ray tube. Let me skip this question number 2. It will lead us to today's lecture. So let's do question number. Sorry. Oh, I've shown you the answer. I don't want to choose that. Question number 3. Question number 3 says, which of the following differentiates science from philosophy? So if you want to answer that, you can put up your hands now. Oba. Hold on, just hold on. Salahu Success, I've asked you to unmute. Salahu Success, I've asked you to unmute. If you don't unmute, I will ask somebody else to unmute. Okay. She's not unmuting. Let's see. Kindness. I've asked you to unmute.
Good afternoon, ma.
Good afternoon, Kindness.
Yes,
So what's
ma.
the answer to number 3?
Experimentation.
Good. Very good. Because paradigm shift is not even among the answer. Paradigm shift is different. But logical reasoning, critical observation are both involved with philosophy and science. In philosophy and science, logical reasoning, critical observation are both involved in philosophy and science. But experimentation is that which you don't find in philosophy. You only find experimentation in science. So the answer to this question is G. The answer to this question is G. Now, let's now go to this question number 2. Most people got those 1 and 2 correctly. Question number 2, put down your hands, put down your hands, put down your hands. Don't worry, we'll have a lot of questions to answer. Let's do much today. We have a lot to cover, please. Thank you. I appreciate that you're putting down your hands up, put down your hands. Thank you. Okay. Now this question says in a cathode ray tube, what is the effect on the beam of particles if it passes through an electromagnetic field? I posted a video, it's an asynchronous video where I did explanation myself on the notes that I couldn't cover in the last class. And I also posted an animation of a cathode ray tube. So if you have listened to this too, you should be able to answer this. Why is everybody, your hands are down? Why are your hands down? Abifarin. Yeah. Abifarin. What's the answer to question number 2? I've asked you to unmute.
All right, ma. Yes, the beam of particles will be deflected. So it's either if the electromagnetic fields are at the cathode part, they'll be deflected towards the cathode. Then if they are at the anode, they'll be deflected towards the anode. So it's between A and
Okay, I've had you. Somebody wants to say something different. If you want to say something different, let's see, Osariere. I hope I called it right. I'm sorry. Yeah,
Good afternoon, ma'am.
good afternoon.
Okay, the answer is A. The beam will get deflected towards the cathode.
Okay. Was that the okay? I've had that. If you have a contrary opinion, Oka for Chukwemeka. Okay, I've asked you to unmute.
Good afternoon, ma.
Good afternoon.
My answer is the beam will be undeflected
It should be undeflected. Why did you say that?
because the electric I don't know how to explain, but the magnetic field and also the electric field are both having an effect on the cathode rays. So if the electric field is pushing it towards the cathode, the magnetic field is pushing it towards the anode. So it will be balancing out. It will both cancel each other out.
Okay, that is a good logic. Very good logic. Okay, very good logic. I think let me just go. I'm enjoying the class actually. Now, so that we understand what cathode ray. Now, before I go, let me do one more thing. I've not answered though, because this answer will lead us to today's class. I'm going to share this again. If you have watched this video, I'm coming. Just give me a minute. If you have watched this cathode ray, have you watched this? If you have watched, please put down your hands. Put down your hands, please. So I can get the information I need. Can you put down your hands, please? Put down your hands. Thank you. I need to get some information. Thank you. Thank you. Please put down your hands so I can get information. Many people are on the chat room, but I'm sorry if I do chat, I'm going to miss a lot of things together. Please, Samuel, put down your hands. Bashit, put down your hands, please. Adebi, put down your hands, please. Thank you. If you have not watched this animation, raise up your hand. If you have not, if you didn't see it, Mayokun, how many hands are up? Hello, Mayokun.
Ma,
How many hands are up?
110, 113, 114. It's changing, ma.
Okay, it's fine. Did you hear me? I said if you have not. I didn't say if you have not. Mayoko.
Yes, ma'am.
Okay, those that cannot log into their LMS. Okay. So we have issues. That's the problem. Okay, now it's fine. I'm going to play it from I posted it, but I know it's not only those people that cannot log in alone that has the issue. Some people can log in, but they can't find it. So let me help you find it, then I will play it. And I think that's what the first thing I will do. For those that can log in but cannot find it, because nobody will be helping you to find anything. So let's see if we can find it. Let me stop sharing. Okay, now look up, let's go back to our LMS page. Okay, this is my LMS page.
Sorry, ma. The LMS page is not showing, ma.
Can you see it now?
Yes, ma.
You can see. Okay.
Yes, ma.
Please, my dear people, I can see your hands up so that you don't get distracted. I want you to see this. Put your hands down now so that we can follow ourselves together, please. Thank you very much. I get it. Some of you have legitimate reasons. Some people don't have real reasons. You didn't just know how to look for it or you skipped it. Put down your hands, please. Put down your hands. So now, week 3, I'm back at week 3 because that was when I gave you this assignment. So this is week 3. I'm back at week 3 as a student. So this is what you will be seeing on your page. What I'm seeing now is what you'll be seeing. Mayokun, can you see week 3?
Yes, ma.
Okay, that's good. So now, under week 3, you have a lot of things. Zoom link, mark your attendance here, asynchronous session. This is my class. This is me. This is me. This video, if you played it, you will see the lecture being repeated and I added some to it. So if you missed anything, you can watch it here at your pace, slowly and however you want it. Now, if you come here, look at this, experimental evidence for the discovery of atom. And of electron. And I said, click on the experimental evidence for the discovery of electron and play the animated video on the cathode ray tube. So if you click this link, if you click this, it will take you to the video. So see, can you see the video? See, I'm doing what you would do. If you now play, see, and all of you watch film now, so I know you can do this. It's just that many people missed it. So I'm going to play it now. I want to believe that you were there. Now, Mark, you do me a favor because I'm not going to play. I want to play from my system. Let me know if you can hear me. Do you understand that?
Yes, ma.
Let me know if you can hear the media. So I'm going to do it again. I'm sharing the cathode ray. It's a 4 minute, less than 4 minutes, 4-minute video. So please watch it. It's on your LMS page already, but that is the beginning of today's class. Don't worry, nobody is rushing anything now. Whatever we do, we do. So let's go.
Sorry, mama. The screen, I can't. Okay, yes, ma. I'm seeing it now.
Can you hear?
No, ma.
Just hold on. It has not started speaking.
Okay, ma.
Discovery. William Crookes
Wait.
discovered cathode rays
Did you hear that?
Yes, ma. Yes, ma.
Okay, so everybody is hearing. So everybody, please listen. Everybody, listen, please.
studying electrical discharge in gases, whereas J.J. Thomson discovered that the cathode ray consists of negatively charged particles called electrons. Production. Cathode rays are produced in a discharge tube. Hence, the discharge tube is generally referred to as the cathode ray tube. The cathode ray tube is a partially evacuated glass tube with cathode and anode placed at the ends of the tube. A vacuum pump is used to partially evacuate the tube. The cathode is connected to the power source with the help of a clip. The tube is supported on a stand. It was found that electric discharge through gases took place only when the pressure inside the tube is lowered and the potential difference between the electrodes was high. To produce cathode rays, high potential difference of 10 kV to 20 kV is applied between the electrodes and the pressure is reduced to 0.0001 millimeter of mercury by means of a vacuum pump. A glow is seen on the walls of the glass tube. The bright fluorescence glow is due to the striking of the rays emitted by the cathode. These rays are cathode rays. Properties of cathode rays. Cathode rays travel in straight lines. When an opaque object is placed in the path of the cathode rays, a shadow is cast on the glass wall opposite to the cathode. This shows that cathode rays travel in straight lines. Cathode rays consist of negatively charged particles. The rays deflect towards the positive plate when the tube is exposed to an electric field. This is because the negatively charged particles in the cathode rays get attracted towards the positive plate. Cathode rays are deflected by the magnetic field. When the tube is exposed to a magnetic field, the cathode rays follow a curved path, showing that they are deflected by the magnetic field. Cathode rays produce X-rays when they impinge on a metal with a high atomic weight. Cathode rays travel with a high speed almost equal to the speed of the light, and hence possess kinetic energy. When cathode rays are made to fall on a paddle wheel, the wheel starts rotating, showing that the rays possess kinetic energy.
Okay, that's good. That's good. Thank you, everybody. Sorry about that. Let me go back to just a minute. Give me a minute. Okay. So let's go back to our question. Now, you have listened to that. Yes, listen to that. So I'll ask the questions again. What is the effect of an electromagnetic field on a cathode ray? Billions of people are raising up their hands now. Okay. Whoever I call, you will tell me the reason why you choose that, your answer. Okay. Sunday Ramon Morola. I've asked you to unmute. Is it you that asked to unmute? I'm not sure. I'm not sure. No. Who did I ask to unmute? Samuel
Yeah.
Miracle.
Yes,
Have
ma'am.
I called you today?
No, ma.
Okay. So what's your answer and why?
My answer is B. The beam will be deflected towards the anode.
Okay, I hear you. Who else is there? If your answer is B, put down your hands, please. If your answer is B, put down your hands. I want somebody who has another answer that wants to defend. You want to defend. Obasoya Anoluwapo. Let's see if I can ask you to unmute. I've asked you, yes, I think. I know. The person is not talking. Please, okay, do me a favor so that it can go around. If you have answered any question today, for now, don't put up your hands. I know you know it, so that everybody can get a chance to say something. Please, let's do it that way. And if I've Morola, please put down your hands. If I've called your name, put down your hands, please. Let it go around. Thank you. Put down your hands. Thank you, so that we can get as many people as possible. I'm asking somebody to Hamza. Are you the one I'm asking to unmute? Yes. Is it Hamzat? Yeah.
Yes,
Hello.
ma'am. The
Yeah.
answer is option D. Good
D.
afternoon, ma'am.
Good afternoon. Yeah.
D. The answer is option D.
What is option D? I can't hear. Is it B or D? What is the? Tell me what is there.
D. None of the above.
Why, dear? Why?
Because it can be deflected towards the cathode back. Since it's a magnetic field, that means going to either be deflected towards the magnetic field or away from it. It can be towards the cathode or towards the anode, and we can't go undeflected because it's deflected towards the magnetic field. So the answer is not there now.
Okay. Thank you very much. Wow, that's I like that reasoning. So I've gotten two reasoning that I like now, and I think let's move on. Let's move on. I know many people will say, I mean, look at what Hamza said now. It cannot be deflected towards the cathode. Deflect. The question is, I mean, the answers you find there is that the beam will be deflected. Do you know the meaning of deflection? Let me go back to my class. Sorry. not my class, the lecture notes I gave last week. The lecture notes I gave last week. So let's quickly see what is in the lecture notes. Just give me a minute. Now this is deflection. Mayokun, can you see my slide?
Yes, ma. Yes, ma.
It's blank now,
No, ma.
Abby.
It's blank now. Yes, ma.
It's
It's blank
blank,
now.
yeah. Don't worry. So this is what you have. This is a deflection. This is cathode, this is anode. The cathode ray is coming from cathode and passing towards the anode. As you saw in that video, that is not a deflection. Going from cathode to anode, this is deflection. Deflect means it's supposed to go straight. It's not going straight. So before it can be deflect, there must be an electric field or a magnetic field. And the question says electromagnetic. So what will happen in an electric and magnetic field? Not all. So this is an electric field. That's what you have in this video. I mean, sorry, in the class, in the PowerPoint. And you saw in that video, you remember in that video, they showed you what happened. I'm going to bring up something in that video. Of course, I will teach it in today's class, but let me show you something in that video again. Cathode ray, yeah. Sorry, it's something I'm not going to wait to the end. In an electric field.
On the glass wall,
sorry.
opposite to the cathode.
This is what you have in an electric field.
Cathode rays consist of negatively charged particles.
So now, listen.
The rays deflect towards the positive plate when the tube.
Mayokun, can you see the video?
No, ma. No, ma.
Okay, don't worry. I'll do it now. You'll be able to see it. Yeah. So now the video says you can see the video now. You should be able to see the video now.
Yes, ma.
So now look at here. See, this is the tube, cathode, anode. Deflection is when you put a field. This is an electric field. Negative plate, positive plate. This is a field. We are introducing an electric field by these plates. This is a negative pole. This is a positive. It is not a cathode and anode again. So just like Hamza said, it cannot be deflected to the cathode or anode. So A and B are incorrect. It cannot be deflected. The deflection is either it's deflected towards a positive plate or negative plate. Since it's a negatively charged particle, you can see the curve. It is deflected towards the positive plate. If the positive plate is up, it will go up. Do we get that? I want to see it in your chat in the chat room. Do we understand what I just said?
Yes, ma.
No, it's not only you. I'm looking at, okay, thank you. I can see now. No, somebody is still saying no. Who is this, my friend, saying no? Okay, hold on. Okay, it's fine. You didn't get it yet. Okay, I'll go by it again. Hold on. I didn't say the answer. I've not said the answer is C. I've not said the answer is C. I've not said the answer is anything. I said the answer cannot be A or B. That's what I've said so far. I've not said the answer. And I've not even said that answer is correct. I'm just saying that you should reason with his logic. He said it cannot be deflected towards the cathode or anode, which is very correct. There's no deflection to the cathode or anode. Okay, so let's do that again. Okay, please pause. I'm not watching you. I'm not seeing your I've not said the answer is D either. It's not, I've not said that, but I want you to know why the answer is what it is. That's what I'm trying to make you know. So look at this. I'm going to play this part of the video again. Listen now.
The rays deflect towards the positive plate when the tube is exposed to an.
Sorry.
The rays deflect towards.
Sorry.
Cathode rays consist of negatively charged particles. The rays deflect towards the positive plate when the tube is exposed to an electric field. This is because the negatively charged particles in the cathode rays get attracted towards the positive plates.
So the rays deflect towards the electric field. So what happens in a magnetic field? Look at, that's deflection. You can see the curving is deflection. So what happens in a magnetic field? Look at it now.
Cathode rays are deflected by the magnetic field. When the tube is exposed to a magnetic field, the cathode rays follow a curved path, showing that they are deflected by the magnetic field.
Now, you see, when a magnetic field also contains north and south pole. That's it. Those are poles. Electric field consists of positive and negative plates or charges. Now, if you put these two poles together, now look at it. Oh, everybody look at it. In the magnetic field, it is coming, and I mentioned it. If you go back and listened to the asynchronous class, I said it will go in the opposite direction. So if the magnetic field, if it is deflecting towards this way, down like this side, in the magnetic field, sorry, beg your pardon, let me rephrase that. If it is deflected towards the positive plate this way, in an electric field, in the magnetic field, it will be deflected towards the opposite direction. So you can see that is what you see in this video. So if we now put the two fields together, what do you think will happen? I want to see your answers now. If you put the two fields together, what should happen? It won't be deflected. Some people are still, is attendance, some people are still marking. Okay, now. Bukumi, you are not interested in the class. You are interested in attendance. Okay. It won't be deflected to either side, because the electric field and the magnetic field will cancel. Beautiful. Oh, beautiful. Now, you got the idea. As many people are listening. So, now, the answer to this question, it will move in a straight line. Beautiful. 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 That's good. Now, let me start, go back to my class. Yeah. And then we can see the question. Now, question number 2. The answer is not A. The answer is not B. The answer could be C or D. Let me tell you the reason why. If you wrote C, you are corrected. The beam will go on deflected because if the magnetic field and the electric field are equal, it will pass through on a straight line. If they are equal, if one is more than the other, it will be the deflection will tilt than the other. If the electric field is much more than the magnetic field, the electric field magnetic field. If the magnetic field is much more than the electric field, it will overpower the electric field. So if you say none of the above, you will still be correct. So the answer, I deliberately put it that way because it is easy for you people to copy yourself. Everybody is writing A, B, D. So I wanted you to think. So the answers, you can see, answer is A for number 1. For number 2, D for number 3. Do you understand now? But, okay. If you want to ask a question about what I've just said, somebody, please, if you want to ask a question, because your chats are too many, I can't. Please, can you come again? It's breaking, okay? We don't set exam. We set exams in a way that makes you think. Because if we don't think, if it's just straightforward that you can just put on Google, then we are not trying to help you to know. I know that now. But ma, if you position, okay, so does anybody want to ask a question? I can't cope with the chat. The chat are too many. Omoladun Baraka, do you want to ask a question? Baraka, do you want to ask a question? I've asked you to unmute, please. Okay, Barakat is not ready for question. Many hands are up. I don't know why. Please let me know why you are putting up your hands. Kinde Israel, do you want to ask a question? I've asked you to unmute. I can't hear you. Hear me? Hello? Hello?
Ma, I can hear you, ma.
Okay. So many hands are up, and I'm trying to get them to talk. They are not talking. Alex, I've asked you to unmute. Your hand is up. I don't know why. I've asked you to unmute. Okay. Since many people are just putting up their hands and they are not talking, I have to move on. I have to move on. So don't worry. If you didn't get that,
Hello.
okay.
Hello, can I ask this
Alex,
question, please, ma'am?
go on.
Yes, ma'am. Please, ma'am. I have a 3 question here. Can I ask the question?
You have 3 questions pertaining to what we have
Yes, yes.
done so far.
Exactly, ma'am. Okay, let's assume that the question now say that the beam of the ray pass through an electric charge. What will now happen to the rays of the beam?
It will be deflected towards the positive plate. If it is
Okay,
electric field, it will be deflected towards the positive plate. If it is in a magnetic field, it will be deflected in an opposite direction to the deflection in an electric field.
Okay. I got. But now, if the ray now pass through a magnetic field, what's now happen to the direction of the
I've
ray?
just answered it, Alex. You are not listening. I've just answered. In an electric field, it will be deflected towards the positive plate. That is if it is only an electric field. If it's in a magnetic field alone, it will be deflected in an opposite direction to the deflection in an electric field. It will still be deflected. Okay, so that takes me to the class for today. It's already after 2. I'm going to do this for the next, I hope I have 10 minutes to do this so that you can get something in this class. Please, can you please mute? Let's quickly do this. It's time already. Some people may have other classes. So please, let's mute. And then we are going to have a test. Let me say that. We are going to have a test, an assessment test. I hope we are hearing now. We will put the information on the LMS page. It will not be today. Don't worry. Calm down. But we'll give you like 3 days notice. It will be in the evening when you can do it. We will not give you too much time. We will release it within the space of a particular time, but we'll have given you notice. We'll be putting it on the LMS page from today, but you will do it this week, the assessment test. From what you did on during my class and what you did during Dr. Joe's class, we'll put it together. We'll set some questions and we'll give you enough information. I cannot answer you whether, if you like, ask me for the area of concentration or whether it's MCQ. I'm not going to answer that. But please don't worry. Just go through what you have learned so far. It's not going to be difficult. And it's going to be on the LMS platform. On the LMS platform. Thank you. So please, let's quickly do something today. Even if it is few parts of the class, we would expatiate further when we get to our physical classes. So please bear with me. I'm going to focus on the class for today. So today we're supposed to look at the quantitative properties quantitative property. Mayokun, can you see this?
Yes, ma. Yes, ma.
Quantitative property of the electron. This was the work of J.J. Thomson. And he also used the cathode ray tube, but this time around, he modified the cathode ray tube. Remember, the normal cathode ray tube, let me go back. The normal cathode ray tube doesn't have electric or magnetic field. This is a cathode ray tube. We passing electrical discharge. That's why it has a cathode and an anode. From the cathode to the anode, through gases at low pressure. So a normal cathode ray tube doesn't have an electric field or a magnetic field. But in the modified cathode ray tube that J.J. Thomson used, sorry about that. I'm just trying to, he modified the cathode ray so that it will have both an electric field and a magnetic field. So what did J.J. Thomson do? And what was his goal? His goal was to give a quantitative property or characteristic, quantity, something you can measure, figure, not just a fact, figure. I remember one of the things we said about the property of the cathode ray is that it has momentum. That means it has mass and velocity. What is the mass? You have to be able to measure it. But you remember at this time, at that time, 1870, there was no instrument that could measure that kind of object. So it cannot take the object and just put it on a weighing balance and say, I want to measure the mass. No. So that is why this experiment he did. He measured the charge over mass or mass over charge, anyone you want. E is for charge, M is mass. So some people call it charge to mass ratio. Some people call it mass to charge ratio. Is either you put E over M or M over E. One will be the inverse of the other. So he measured the charge to mass ratio of the electron. Since he cannot measure the electron, and we said it's a charged object, so we need to know what is the quantity of that charge, what is the mass of the electron. So now he based it on this principle. The principle that a negatively charged particle, this time we are talking about electron, is deflected in an electric field. That's what we just said. So this electron, or a negatively charged object, is coming straight. When it gets into an electric field made up of positive and negative plates, it is deflected. You can see the deflection towards the positive plate. Is deflected towards the positive plate. That is the first understanding. Then the next understanding is that in a magnetic field, the same negatively charged object is deflected in a circular arc in opposite direction. That was the question Alex asked. In an opposite direction to that in an electric field. So you can see the deflection. And the magnetic field is symbolized with this circle. That's the magnetic field. So when we put both the electric and magnetic field together, that's electromagnetic. See, it cancels out. That is why I said option C will be correct. It is not deflected. But that is because both the electric field and the magnetic field, in this case, are equal. When both fields are present, the forces cancel out. If they are equal, if they are not equal, the deflection may decrease or may be large, as the case may be. So that is what you have. Now, what did you do? So look at the modified cathode ray tube used by J.J. Thomson. I'm going to post this on your page, so don't worry. Look at the modified cathode ray tube. Can you see that? This is the normal cathode ray. We have the cathode and anode. Then he put this plate, this yellow thing that you are seeing is the electric field. You can see arrow electric field. And the circle, the blue, is signifying the magnetic field. Both are here. Now, if he reduces any of this, see, now this is where he's measuring the deflection. At the end, this green place, is measuring the deflection. If they are both equal, it will go undeflected. Straight, this red line. If it changes, the deflection can range from any part of this arc. Whether it is magnetic field that is more or the electric field that is more. You can see. Do you understand that? I know most of you want me to say it over and over again, but it won't change what it is. So what I just said is that in a modified cathode ray, the electric and magnetic field are incorporated. That is what J.J. Thomson did. And he began to vary both the electric and magnetic field to see the deflection. When both of them are equal, are balanced, when they are balanced, the ray goes undeflected. But when he varied them and changes them, maybe reduce the electric field, increase the magnetic field, there is also variation in the deflection that you see at the end here. So let's look at don't worry, this part, I will be quick. You may be saying, it's fast. I will post it because it will lead us to the figure. Don't worry. Don't let it overwhelm you. I've said it again, don't worry. You may not get it the first time, you will get it by the time you look at it the second or third time. Please calm down, please. So now, in an electric field, we have force, we have the electric field, we have the charge. So the force on a charged object, we are going to calculations now. So calm down. Please don't be distracted. I've said it over and over again. Calm down. Don't let it overwhelm you. It's very simple. If you are not typing as I'm explaining, you will get it. If you are trying to raise up your hand as I'm explaining, you will miss one thing. Are we still together? Mayokun, can you hear me?
Yes, ma'am.
Okay.
Yes, ma'am.
The force on an object in an electric field, it depends on the strength of the electric field and the charge. And if we write that out, we can say force equals to E multiplied by E. The E's are different. Some textbook may not use capital E for electric field, but I've defined it. The force on a charged object in an electric field is electric field strength multiplied by charge on the object, which is the small letter E. In a magnetic field, the force depends on the magnetic field strength. This time around, we are using B for the magnetic field strength. We use capital E for the electric field strength. We are using capital B for the electric field strength. We are using E for the charge because it is still the same object, and V for the velocity of the object because it is traveling in an arc. Don't worry, you will get that. So we have force on an electric field strength multiplied by charge, force in a magnetic field equals to magnetic field strength multiplied by charge multiplied by velocity on the object. If we balance the two together, this is force. F equals to EE, F equals to EE. If F is equal to this F, what will happen? That's what we are saying. Since we balance the force, this is what we have. I hope we are not lost. If you are still following me, let me see you in the chat room. If you are still following, thank you. Thank you. Thank you. They are still following me. Good. Okay. Let's leave it now. Let's leave it now. So now, if I make the velocity the subject of the formula, you know this is what I will get, Abby. And I can cancel the charge since the charge is the same thing. Abby? So if I cancel the charge, I'm going to get velocity equals to E over B. What is E? Electric field strength over magnetic field strength. That's the velocity of a charged sub-object. Are we together? Does that make sense? Thank you. That's the first part. You know, it's not difficult now. It's not difficult. Okay. So now look here, everybody. Now, the velocity is equal to the electric field strength by magnetic field strength. Now, since these two fields could be measured, then velocity of the cathode ray would then be determined and be used in further calculation. So that means if we can measure, if we can get the electric field strength, you can get the magnetic field strength, you can get the velocity. We need the velocity. In the next derivation, you will see why we need the velocity. We are looking for charge to mass ratio. That's what we want to get to. Don't forget. And we need our V because we are to determine the mass. Just look at what I'm doing. In a magnetic field, a charged object moves in a direction of the arc. I've said that. And the radius of that arc is R. And you have done centrifugal force, centripetal force. Centrifugal force is given by mv squared over r. You know that. This is where our m comes from. We are trying to get m. Don't forget what I'm saying. Our mass. Are we together? Don't be confused. Just look at this derivation. I'm sure you'll get it. So recall that in a magnetic field, this is our equation. Force on a charged object in a magnetic field is B multiplied by EV. That's strength, charge, velocity. And we also say the centrifugal force on an electron on any charged object on any object in a magnetic field, the centrifugal force is mv squared over r. This is a force in the magnetic field. This is another force in the magnetic field. We can equate these two forces together. These two forces, the forces in the magnetic field. Please, I'm not interested in Moodle or anything. I'm interested in you getting this. So all of you that are asking questions while I'm teaching, this may be the reason why I'm not going to place it anywhere. I need you to pay attention, please. So if we equate these two forces, we have done the one for electric and magnetic to get an expression for V. But this time around, we want to get an expression for M. So look at it. What have I done here? I've equated the two forces in the magnetic field. And I know that those of you that are very quick in mathematics can make E over M the subject of this formula. What I'm going to do next is make E over M the subject of this formula. Everybody do that. I'm going to give you a few minutes to do that. Make E over M the subject of this formula. I want to see it. So since you know how to, you can chat. Everybody, don't let me make that as an assignment. Try and make E over M. Quickly do it. The subject of this formula. I'm looking at your chart. Make E over M the subject of this formula. Okay. I don't need you to do too much. Just make E over M the subject of this formula. Not capital E over M. I need you to write exactly what I'm saying. Make E over M. I can see some people making sense. Make E over M the subject of this formula. I can't see enough answers. Don't copy what other people are doing. You to do it in your own book. Okay, I've seen it enough, at least quite a number of people, but I'm not impressed though. I'm not impressed with the number of people that are answering. Many people are not doing anything. Okay, that's good. So if you make E over M, so now, okay, that's good. Look up, everybody, that's good. I like the trial. Many people got it right. Some didn't. You shouldn't have a V squared again. You remember, if you make E over M the subject of the formula, that means B and V will come to the other side, Shibi. B and V will come under, will become a denominator on the right-hand side. V squared. I mean, are we together? Please stop writing. It's okay. It's okay. Okay. Thank you. for those that are listening. So look up, everybody. I want to make, it can be V over E over M or M over E, anyone you want. So if I want to make E over M the subject of the formula, and I bring M to this side, V will come here to this other side. B and V will come to the right-hand side. You know, the V in the denominator will cancel one of the V upstairs. So we cannot have V squared again. Do you get that? We cannot have V squared. That's good. Feti, I like the fact that you slap your own. Yes, that's good. Yes, that's good. But I'm not looking at it again, please. So that I can get now. So this is what you will have. Does anybody know why I got this or how I got this? You know what you will get will be V over BR. And remember that your V, what you will get is V over BR. Remember that your V in the previous slide, what is your V in the previous slide? What is our V in the previous slide? Anybody? What is our V in the previous slide? Yes, I wrote B squared. Yes, E over B. So the answer to this, let me write that. This permit me. I'm going to escape because somebody is already asking me, why did I write this? Okay. You know, if I make U over M the subject of this formula, can you see my slide? Can you see?
Yes, ma. Yes, ma.
Okay. If I make U over M the subject of this formula, beg your pardon, I want to show you what I will get. No, oh yeah. Yes. E over M will be equal to V over BR. And V is equal to E over B. So if you put V over B, instead of putting V here, so that means you will now have E. I hope everybody is seeing, people that are complaining. E over M will now be equal to E over B multiplied by BR. Did you get that? That is why I have it to be equal to this. That's why I have it to be equal to E over M equals to E over B squared R. Do you get that? Do you get that? Please, if you didn't get it and you were following me and you didn't get it, raise up your hand. Don't raise up your hand because there are many hands up. I can see one no, ma. So all these hands didn't get me. Okay. Look at it again. Oh. I said you should make this the subject of formula. Now that's why I'm working it out so that you can see how I did it. If you make this the subject of the formula, if you make E over M the subject of this formula, you are going to get V over BR. And we have said that V over BR is E over B. So that means your E over M, wherever you see V, put capital E over B. That's what I did. Then you would have this. I think with this, I have to stop here. It's already 2:30. We have overshot our yeah. I think yeah. We are back together now. So many hands up. Your hands confused me throughout because I've begged you to put your hands down. You still did not put your hands down. I don't know why your hands. Like Obasoya, why is your hands up? You don't know. Why is your hands up? Why? Okay. Now for now. How about the unit? Okay. You know, I didn't even go. I don't want to go to the final answer here. Leave the answer. I want you to get it up to E over B. The final answer. Once you get the figures, forget the figure now. I will talk about the figure later when we go to class. Okay, Mushina, do you want to talk? I'm going to ask you to. You have put down your hands again. I don't get. Okay, Abibat, I've asked you to unmute. Do you have anything to say to what we have just done so I can round up the class?
Sorry, ma, that question that you gave us, if it was a test question, are we to choose C or D?
If it was the test question. No, the test question will not confuse you. Test questions don't have two options. Now, listen to me. In a test, we may deliberately, I'm not going to say deliberately, because sometimes if the answer is not there, they will tell you what to do. If you feel the answer is not in the question, there is an option to choose. Maybe you have done your own and the answer is not in the option. There is an option to choose. So nobody would give you a question in a test that would have two options. Nobody. This is to test, because I know all of you are seeing yourself, what you are posting, and I don't want people to copy. I deliberately put it there. So you can never be confused in a test. Do you understand that? You can mute now. Please, can mute now. Please mute. Thank you. I don't think we have. Okay, this will be my last question. Olaogun, I've asked you to unmute.
Okay. Good afternoon, ma.
Good afternoon.
Based on the cathode ray, this thing you showed us the other time. Are you hearing me, ma?
I can hear you.
You said the electrons, the cathode rays, they are deflected toward the positive plate. But from my former knowledge, it seems the positive plate of an electric supply is called the cathode. But based on what I see here now, like it is being denoted by the anode.
If you have a former knowledge that is contrary to what I've taught you, leave your former knowledge. Stick to what I have taught you now, because what I've taught you is not confusing. There is difference between the cathode and the plates of the electric field. So don't mix the plate of the electric field and the cathode and the anode of the cathode ray tube together. Do you understand? Please don't mix the cathode and the anode ray, cathode and the anode plates of the cathode ray tube. That normally we have to pass electricity. That's what they did. If you remember what a cathode ray is, passing an electric discharged into gases at low pressure. And that's why we have the cathode and the anode. And we said that there is a ray flowing from the cathode moving towards the anode. And because it is moving towards the anode, which is a positive plate, please, can you mute? Because of the echo, thank you. That's why it is called the cathode ray. It is emanating from the cathode, negative, and it is drawn to the anode, positive. So whatever you have that is different from that, leave it for this particular course. Stick to what I have taught you for this course. Thank you. Okay, I've said that is the last. So, like I said, we'll give you enough time. I'm going to look at if you are unable to write your attendance and you're in this class, please let me see your hands up. I want to see if you're unable to mark attendance. Quickly do that. You're unable to mark attendance. We have over close to 500 people on this in the class. So if you're unable to mark attendance. So if only 50 people are unable to mark attendance, although I'm going to look at it, the best I would do is to use your attendance after each class. The Zoom always gives us a post-attendee report. So I can use that for your attendance. But those people because what I have here is like 45 So what I have here is like 45 people. Mayokun, can you hear me?
Yes, ma'am. Yes, ma'am.
So like 45 people that are raising their hands that they can't. And I don't know why. Because if over 400 people are able to mark attendance and only 45 cannot, I don't know, that must be a problem. That's an issue. Except those that are unable to join the LMS page. I don't know. But don't worry, we'll sort it out. We'll sort it out. So don't worry about that. Because of other classes, we need to go now. Thank you very much. So like I said, we will give you enough time, but keep watching your LMS to know the time. We give you like, I would love it to fall towards the weekend, anytime from Friday. You had late, and it will be for a short time. So what we will give you enough notice so that you will not complain. And those of you that are in the know, if you are on any WhatsApp or any platform, please inform others that CHM 101 test is going to happen on so time and date. And we won't give too much. You know, the thing will, the LMS will shut you out. Once you log in the time, you won't be able to log. To do anything after the time has elapsed. So don't let the time elapse. So do that, and by God's grace, we'll wrap up next week. Thank you very much, everybody. Good night.
Thank you, ma.
Thank you, Mayokun. You have been a wonderful host today. Thank you very much.
Yes, ma.
Okay, thank you, everyone.